Okay, so
more related rates. We're just going to keep practicing them because these are the kind of things, honestly, that you just get better by practicing. So we'll go through this one together, and then we have another packet that we'll kind of go through together too, so that we just get to practice. Okay, so you remember what you're going to do. You're going to go through and identify what variables you're dealing with. That helps you know what formula you're looking to use, and then identify the rates that you've been given and the rates that you're looking for. So I've got radius of a sphere. They gave me a rate, and then I have surface area of the sphere. So it looks like I'm doing surface area of the sphere, which is probably not one that you have memorized right off the top of your head. We had it on the front. Surface area of the sphere is 4 pi r squared. So I'm going to write that formula down just so I'm flip back and forth. Okay, and I have the radius of the sphere is decreasing at a rate of 2 inches per minute. So that's going to be dr dt. So I have dr dt equals, now it says increasing, so it's positive, 2 inches per minute. And they asked for a rate of change of the surface area. So this one actually seems like it might not be too hard. So I am looking for dA dt. So that's what I'm trying to find. And it should be in inches squared per minute. Because remember, all derivatives are rates. They're rates of change. They're slopes. So it's a rate, which means it has to be per some kind of time. And it's area. And area is squared, and we're in inches. So it should be inches squared per minute when we finish. Okay, so what now? We're going to take the derivative. So we're going to ddt both sides. Take the derivative of both sides. And that's going to give me dA dt on the left. On the right, again, I'll probably say it 100 more times before the year's over. Pi is a constant. So you do not have to product rule this because 4 is a constant. So 4 pi is all one constant. So you can just power rule this. So it's 8 pi r. But because we were doing this in terms of t, and r isn't t, you have to dr dt. Is everybody okay that far? Does that make sense? Okay, now all I have to do now is plug in the things that I've been given because I know dr dt, and in the problem they gave me the instantaneous radius as 6. So I'm just going to plug in. So dA dt equals 8 pi times 6. That would be 6 inches times 2 inches per minute. If you are a label stickler and you want to make sure you got all your labels correct. Now I would just leave this in terms of pi and just multiply your constants. So 8 times 6 times 2, which that's 48 times 2, 96 pi inches squared per minute.
Oh wow, you do have a tiny class.
I don't really, they're gone. They're gone. Okay, so you guys go ahead and try the next one, and I am going to go talk with her class for just a minute. And I'll do that. See what you can do. That one was easy, right? Yes. Sure. That one wasn't bad, so just...
I'm going to do over.
And this one,
Yeah.
what phone number are you using? Are you using the volume of that area? Volume? Because it's cubic inches. I didn't write the first time.
I'm sure it's your.
Use that Senza stuff, that material they make jumpsuits and stuff out of. It's not suede.
I feel like I wouldn't have.
Can't remember. Remind me, like, y'all know what I'm talking about. Like it's velour, that's what it is. You know, like they wore in the 80s a lot.
Did y'all get it? Do you feel like you got it?
Yes.
Awesome. Okay. Spherical balloon spanning at a rate of 60 pi cubic inches per second. Half the surface area. Oh, good. Same. Let's see, they gave me DA. We already took the derivative up there, so.
Wouldn't it be volume because it's cubic?
Oh, this is, you're right. It's dV. But they did say how fast is the surface area, so I am looking for dA dt.
Oh, no.
So actually, so what's going to happen in this one? It's going to be 2 steps. You're going to have 2 steps. So- So, we know dA dt because we already did it. So it's right there. So So I'm gonna go ahead and write that one down. And then we're gonna need, and they gave us dV dt, so we're gonna need the volume formula. Did y'all write it down? Volume of a sphere,
It's
4/3 pi r, 4/3 pi r cubed. Okay, so I'm gonna go ahead and take the derivative of that. So I'm gonna d dt both sides. Very similarly, 4/3 pi is a constant, so you don't have the product rule, you just power rule this. And you get 4 pi r squared dr dt. Now, since I am looking for I'm looking for dA dt, which they gave me the radius of 4. What I don't have, and that I need in order to find dA dt is dr dt. I don't know dr dt. They didn't give it to me in the information. I haven't calculated it, but I do know dV dt. And I could plug dV dt in and solve for dr dt. So that's what I'm going to do. So dV dt is 60 pi. And now I am solving for dr dt. I need to get this by itself. So I'm going to divide by 4 pi r squared. I can go ahead and plug in the 4 if you want to. Or we can plug it in over here in just a minute. So my pi's cancel. 4 goes into 60 15 times. So I have 15 over r squared equals dr dt. Now I'm going to plug that right here, and I'll be able to get what I'm looking for. So dA dt equals 8 pi, and they said our instantaneous radius is 4 times dr dt, which we found to be 15 over r squared, or over 4 squared. So that's going to be 8 pi 4 is 15 over 16. So I end up with 30 pi. This is dA dt, so it's inches squared per second. Y'all okay? So it was just 2 steps, but they weren't difficult steps, really.
I like this, I understand that.
Yeah, I think, I like them too. I think they're kind of fun. Okay, so we're going to do another, we'll start another packet practice. As soon as I remember where I put them. Oh, that's okay. I put them right here, so I would remember where I put them. You'll see as we go through these that the same types of problems repeat themselves over and over again because they're the types of problems that we use this for. So if you can get used to doing them, it definitely helps. So this says earlier in the year we studied the basic definition of calculus as the study of change. I don't know if I necessarily called it that or not, but that is what it is because it's basically the study of a derivative, and the derivative is a slope. And slope is rate of change. So that's what calculus is. Anytime we use words like increasing, decreasing, growing, shrinking, that's calculus. Change occurs over time, so when we talk about how quantities change, we're talking about the derivative of a quantity with respect to time. That's where d over dt comes from. So, if we were going to write these things mathematically, Mortimer is growing at the rate of 3 inches per year. I'm assuming they mean he's getting 3 inches a year taller. So if we were gonna write this out, we would write that as dH dt. His height is changing with respect to time, 3 inches per year. That's it. But if your stock portfolio is losing 5 cents per day, so we'll say ds dt for your stock, that's going to be minus 5 cents per day. So you have to take into account whether something is increasing or decreasing. I will be honest with you, that is usually the thing I miss. I miss negative signs all the time because I forget to notice if it's increasing or decreasing. Radius of a circle gets larger by 4 feet per hour. So that would be dr dt. So d radius, the change in the radius over the change in the time is 4 feet per hour. Outside temperature is dropping. In this case, I would d capital T over d lowercase t. Lowercase t being time, capital T being temperature, equals 5 degrees Fahrenheit per minute. Oh, dropping, see, I already did it. Minus 5 degrees Fahrenheit per minute. Alright, so length of a rectangle, decreasing, I should highlight that so I don't miss. Length of a rectangle is decreasing by 2 inches per second. Width is increasing. Alright, so I'm going to have one positive, one negative. By 3 inches per second. What is the length in inches? The width, how fast is perimeter and area changing? Alright, we got a lot going on here, but I have length and width, and then they told me in A and B I'm talking perimeter and area. So we're going to do 2 separate problems. Let's do perimeter first because they listed that as A. Perimeter of a rectangle, what's the formula? That's area. For perimeter? How do you find perimeter of anything?
You take the sides and
Add them up. But on a rectangle, what about these two and these two? 2 length plus 2w. So perimeter equals 2l plus 2w. That's how you find perimeter. So we are going to d dt both sides. And that would give me dp dt equals 2 dl dt plus 2 dw dt. I am looking for how fast the perimeter is changing. So I am looking for dp dt. So hopefully I have a dl dt and a dw dt. So that's where I have this decreasing and increasing. Make sure I don't miss them. Length is decreasing. So that's your dl dt. So I'm going to do 2 times negative 2 inches per second. My width is increasing by 3. So that's 2 times positive 3. And we get negative 4 plus 6. So dp dt is increasing by 2 inches per second. Okay, everybody good? Same rectangle. Now we're doing parts. So this is A. So let's do B, which is area. Area of a rectangle is length times width, which means you will have to product rule this when you take the derivative. Okay, is everybody okay on the derivative? I got dl dt times w plus dw dt times L. Now we just plug in what we know and solve. So in this case, I know dl dt, that was -2. The w's, the instantaneous rate, is 6. dw dt was +3. dl dt is 10. So I got dA dt equals 18. Now this is area, so it should be inches squared per second. That good? On example 3, they gave us a right triangle, so I'm going to draw a picture. Whose sides are changing. It has sides of 30 and 40 inches at a particular instant. So those are instantaneous legs or sides. If the shorter of these two sides is increasing at 3 inches per second and the longer side is decreasing at 5 inches per second, how fast is the area and the hypotenuse changing? So because they asked for area, I'm going to just call this base and this height. And then I'll call this C because it's the hypotenuse, just to keep things straight. Okay, so let's do area first. Area of a rectangle, so that's going to be area equals 1/2 base times height. Instead of writing it as base, probably 9 times out of 10 in Algebra 2, I would write that as base times height divided by 2. But in calculus, it makes more sense to write it as 1/2 base times height because then you clearly see the 1/2 as a constant instead of thinking, oh, I got a quotient rule. So write it as 1/2 base times height. Got a d dt both sides. You will have to product rule because you do have two pieces. Okay, so that's what it looks like. I'm going to simplify it a little bit before I plug anything in. But that's just my straight product rule. The derivative of the first piece was 1/2 dB dt times the second piece just like it is, so that's where the h comes from. Plus the derivative of the second piece. Well, the derivative of the h is just 1, so I didn't write the 1, but I did write the dh dt times the first piece just like it is. So actually, I don't think I have to simplify because we actually have these, don't we? We have two sides increasing. The shorter of these two sides is increasing at 3 inches per second. So because of the way I drew mine, it won't matter. It will come out the same either way. But because of the way I drew mine, I'm going to say that my h is my shorter side. It won't matter, but because it just looks like it is. So the shorter of these two sides is increasing by 3 inches. So that's going to be my h. So I have dh dt equals 3 inches per second. My dv dt is -5 inches per second. So when I plug in, I have 1/2 times -5 times, let's see, so this is 30, this is 40. So h is 30 plus 3 minus 1/2 is 40. Then just simplify. So I ended up with negative 15 inches squared per second after simplifying everything. Okay, so now they're asking me about the hypotenuse. So it's a Pythagorean theorem. I'm going to go ahead and use the letters that I wrote. So it would be h squared plus b squared equals c squared. You can d dt both sides. So I get 2h dh dt plus 2b db dt equals 2c dc dt. Plug in what you know, and you should be able to solve. I am solving this time. I'm looking for the change in the hypotenuse. So I'm solving for dc dt. So I know my h is 30, my b is 40. I know dh dt, I know db dt because they gave me those. The only thing you don't know, that's not what you're solving for, is c, but you can find it with Pythagorean theorem because I know the other two legs. So we're going to have to do that before we can finish our plug-in. So real quick, c squared equals the square root of 30 squared plus 40 squared. I have no idea if that comes out or not. I should.
It comes out as
It comes out as, oh, it's Pythagorean triple. Dumb. That's stupid. It is a Pythagorean triple. C comes out to be 50, because that would be a 3, 4, 5. So easy. Okay, so 2 times 30 times 3 plus 2 times 40 times negative 5 equals 2 times 50 dc dt. Now it's just simplifying. 180 minus 400. Negative 22. Right? Negative 2.2. Did I see this one before? Oh, I should leave it as a fraction. Negative 11/5 inches. So that's your hypotenuse. Am I good? Sort of? Okay, so this is, so before when we were working through the little tables, that was one curriculum, that way of teaching related rates. This is another one. It's just explaining that you need a method to solve related rates problems. You gotta have a strategy. You're looking for words like increasing, decreasing, growing, shrinking, changing. This says follow 11 easy steps. The first one is huge. You've been hearing this since way, way, way back. Draw a picture. Label. Make sure you sketch because it definitely, definitely helps. Label all sides and linear quantities that change throughout the life of the problem. As convenient variables of your choice, you get to choose. So when we did the one triangle, I used base and height because we were doing an area problem, so it made sense to use base and height. Sometimes it makes sense to use A and B if you're doing a Pythagorean problem, because you're used to a squared plus b squared equals c squared. So use things that make sense to you. Obviously, if you're going to be using the formulas that we all know or that we're learning, and for spheres and things like that, you have to label the radius and the height and those things. So make sure that you're labeling everything correctly. Label all of your given rates with the correct sign. That's my big problem. I always forget. But make sure that you identify whether it says increasing or decreasing, and that you put that negative sign if it's decreasing. Identify the snapshot moment. That's the instantaneous moment. Because those are not derivatives. So you're always looking for that instantaneous